Hi everyone. Today we are going to discuss about the module 2. The topic is lime, cement, aggregate and concrete blocks. So before discussing about the module 2, what we discussed about the module 1, we have seen the different type of the building materials like stone, bricks and concrete blocks. In a stone, we discussed about the various classification of stone and the testing of the stone, then the performance of the different material of the stones. In case of the brick, we have discussed about the different classification of the bricks and various tests on the brick. We have discussed about elaborately for in the module 1. Now we are going to discuss about elaborate in the module 2, what we are seeing here. So we are going to see about the various ingredient of the limestone and various classification of the lime and the various ingredient of the cement and how we are going to manufacturing of the ordinary Portland cements and various of the types of the cement and various importance of the cement in the construction fields. So further in the module 2, we are going to discuss about the aggregate, exclusively for the fine aggregate and the coarse aggregate and different characteristics of the aggregate. And coming to the concrete of the block, grading of the concrete as well as the property of the concrete, we are going to discuss about in the module. Okay, so what is it? This course objective of the module 2? Student need to understand the classification for the construction use of the lines. So here various classifications of lines. So first one is a fat line and a hydraulic line and a poor line. What is this line? How the manufacturing of the line? What is the application of the each and every different line? We are going to discuss in the these modules. Next, student need to learn about the various cement constituents materials and how the manufacturing and various type of the cement we are using for the construction field. So as of now, we know the different type of the cement, ordinary Portland cement, PPC, and PSC and rapid hardening cement and low heat cement. We are having different type of the cement available. Each and every type with a unique characteristics and properties which you can able to use the different application of the different type of the cement in the our construction field. Then student need to study the different types of the properties of the aggregate. So various properties are there, mainly for the strength, hardness, durability, shape and texture, and specific gravity. So these are for the exclusively for the properties of the aggregate. Then students need to understanding the different grading systems and the properties of concrete. As of now, we know the various properties of the concrete is the workability is one of the prime is the concrete, strength and durability and water tightness and resistance to the fire. These are the main properties of the concrete. And students need to learn the use of the concrete block in the construction purposes. We can know where are we using the concrete block mainly for wall construction, partition walls, pavement, boundary walls, and load bearing walls. So these are things are students you can use for the concrete blocks. Okay. So now we are going to discuss the elaborately for the different type of the building materials. One is for a lime. So lime is a binding material. It's a traditional material. Before invention of the cement, they are used for the construction purpose for the lime. So it's obtained from the boning of the limestone. It's widely used for the mortar, plastering, whitewashing, and establishing as the work we are used for the limes. So what are the ingredients of the limestone? The limestone is the raw material used for the manufacturing of the lime. So mainly consist of the earth for mainly for calcium carbonate. So this is the main ingredient of the limestone, which give the purity as well as the strength of the lime. Calcium carbonate is important using in our limes. So next ingredient is the magnesium carbonate. So present in the small quantity of the magnesium in the lime, it excess make the lime it be a slow setting time will be very slow. So next one will be silica is the main ingredient. So it gives the hydraulical properties to the lime. When you present in the small amount of the silica also it gives the more hydraulic properties in the lines. So alumina, it's be a very quick setting. So a small quantity is be required to by setting of the lines. Then after that, color formation, it's some of ingredient will be called the iron oxide. It gives the color as well as the for the hardness. So other impurities, the clay, alkalis, and organic matter cases are available. So it will reduce the quality of the limestone. So these are the main constituents of the limestone. How the manufacturing is happening for the limestone? So we having a quarry of the limestone quarry. From that we are taking from the limestone from the quarry. For that using we are going to burning for the limestone using the clean around the temperatures 900 to the 1100 degrees Celsius we are burning. What happen when this burning is happen automatically carbon dioxide evaporated. So moisture as well as the carbon dioxide was removing we will get to for the quick climb. So very quick line properties is their good binding properties. You certainly easily can able to do the binding of this line as well as the fine as well as the coarse aggregate. So workability and the plasticity very easy for the quick line. The high water retention and antibacterial and antiseptic is very important. Eco-friendly and sustainable for using for this quick line. Where you're using the line, usually for the mortar, in the brick as well as the stone masonry. So using the plaster we'll get for the smooth as well as the durable finish of the surfaces. Used for the whitewashing purposes and all the walls and the surfaces. So this hydraulic line we can use it for the soil stabilization in the construction work. So used in the sewerage treatment and water purification we using for this quick lines. So when you're using the binding material for line, so what is the advantage of other binding material? It will improve the workability as well as the finish of the business. So allow the masonry to be breathed, to take more time to adjustment of the material. Good thermal insulation. It also very economical. It's locally available, eco-friendly material. So automatically it will increase the durability of this structure. So when coming to discussing disadvantages, the line will be expanded, the crack and the shrinkage will be occur. So setting time is very low and compared to the cement, reduce the strength and durability because of the setting times will be low. So affect the color as well as the appearance. So these are the common disadvantages of the impurities of the or lines. So having a different type of classification of the line will be available. It's based on the purity as well as the properties of the lines. So we have three classification of the line. One is a fat line. The fat line also called as a rich line or high calcium line. So they are mainly contain the calcium oxide is 90 to 90%, 95% will be available in the raw material of the line. So it's a purely white color. If you're adding the water, if you shakes vigorously with the water, it will take for high plasticities. But what will happen when you started to the water adding slags, we set very slowly in the air. So this type of the fat line we are going to use it for the whitewashing and the plastering purposes. For this fat line, its a property is a high calcium content to give the more strength and it be an excellent workability. It produce the smooth as well as the strong finish. So practical application using the fat line we can use for the whitewashing, plastering purposes and finishing purposes. So next one is the hydraulic lime. In hydraulic lime, the main ingredient is to be clay as well as the silica. So using for this, this type of the lime name itself, we can say the hydraulic lime. So it sits under the water as well as the in air. So this lime you can use for in the masonry as well as the foundation work. Again, the hydraulic lime is classified into three types: the freely hydraulic lime, moderately hydraulic lime, and eminently maybe hydraulic limes. So feebly the hydraulic lime is the low content, clay content when compared to the other lime. It is set very slowly. So moderately hydraulic lime is a medium clay content and set is to be a moderately. Eminently hydraulic lime is a clay content will be very high. It's set very quickly and also the strength will be increases. So this hydraulic lime is a properties develop the strength both as well as the water and will be also. It's a good durability, more resistant to the it's a weatherings. So this hydraulic line using the masonry work, foundation, dams, retaining walls, wherever the hydraulic sources are there, we can use for this hydraulic lamps. So next classification is a poor line. So in the poor line, it contains more impurities in the presence of the poor line. When you're giving the hydration, it dislikes very slowly. The plastic is also very less. As a weak binding property when compared to the hydraulic lime as well as the fat lime. Used to the inferior construction works, not important so what we can use it for the poor lime compared to the fat as well as the hydraulic limes. The properties of the hydraulic lime, low calcium content, So automatically strength and workability and durable also be very less. So we can use this poor hydraulic limes in the ordinary masonry work. It's a temporary structure work, filling and plastering of the rough work we can use for this poor limes. So we can see the different classification of the lime. What are the properties are there? If you see the content of the calcium, rich lime having a 90 to 90% will be available calcium. In hydraulic lime, it will be a moderate in the calcium content. Now, calcium content is very, very low in case of the lean limes. When slaking properties is a vigorously automatically slaking properties. Hydraulic lime is a moderate and poor lime is a very low. Setting time of the and the lime is very slow in the air for a fat lime. Sets in the air and water is very fastly in the hydraulic lime. Slow in the air only for the it's a poor lime. Strength. Fat lime is the strength is more. Hydraulic lime is very high, very low in the poor strength. When see the plasticity and durability, flat lime is high for the plasticity as well as the durability. Hydraulic lime is plasticity is very is a moderate and durability is very high when compared to the other limes. Plasticity and durability is very low using for the poor limes. So typically where we can use the three types of the lime is one is whitewashing we can use and plastering purposes, masonry and foundation work and inferior and construction work we are using for poor limes. For some of the importance when using for lime in construction, so lime is to be acting as a building material. The binding with sand, that is means a fine aggregate and a coarse aggregate will be together. That's why we are saying the binding, using the binding material. So it gives the strength as well as the durability. So it will contribute to the strength and long-term durability of the structure. So lime used for in concrete, mortar as well as the plastering purposes. This is the essential for the and finishing of the various work. So it will be improve the workability to resist the weathering action. So it is suitable and traditional modern constructions purposes. But yeah, that's why we are using for heritage structure also for the lime. So what is the key point? So limestone is the purity and for the composition determining the different type of the lime. Choose the right type of the lime as per our requirement of the work. Hydraulic lime as well as the fat lime are very stronger and more durable when compared to the poor limes. So proper selection and lime is ensure the economy and long life of the construction. So lime is a eco-friendly and sustainable building materials. So overall, if you see the summary of the this lime, so fat lime is a very rich in calcium and best for the plastering and relative whitewashing purposes. So hydraulic limes contains the clay as well as the silica and used for strong masonry and foundation work. In case of the poor lime, it's more impurity power will be there. The low grade construction work, filling work only we can able to use for this work, poor lime work. So next is a building material will be a cement. So cement we know is a finely powder, it's a binding material. Before the cement, we are used for the lime. Now we are using for the cement that hardens, that is mixed with the water. It bind with the sand as well as the aggregate. When we are together, we'll get the very good parts. It is one of the most important construction material for in modern engineering. Okay, so various constitution of the cement is first main constituent is the lime. It's one of the prime the binding materials. So lime is present for 60 to 65 percentage is available in the during for our cement. So when you're having a 60 to 65 percentage, it provides the strength as well as the soundness to the cement. So main constituent of this were lime. Then alumina, we're having a little bit percentage is 3 to 8 percentage. It'd be very quick setting properties and be increasing the early strength of the materials. So next there is silica. Silica having a range between the 17 to 25 percentage is there in our cement. It gives the most strength and increasing the durability. So iron oxide, the minimum content should be there in 0.5 to 6 percentage. Iron oxide reduces the color as well as the hardness. So it will be affect for increasing strength and slightly. And magnesium is a 1 to 3 percentage. Excess of the causes the unsounds of the cement. We cannot able to use the unsounds of the cement in the construction work. will be helps strength development in a small amount of the present in the mechanism. And sulfur trioxide, so 1 to 3% in our symptom. We're having a small quantity of the sulfur trioxide, it gives the improve the soundness and help the daily strength of the materials. So alkalinity, small quantity only we are having in the purpose. If you're having small quantity also, it is harmful in the excess, may causes for expansion during the changing of the climate. So gypsum is an important properties of this cement to increase in the setting times. So normally gypsum is using during the manufacturing of the cement, we are adding the 2 to 5% of during the grinding in the time and control the setting time of cement. Okay. So where you can use the cement normally in the case of the masonry work on stone masonry or big masonry, what are things we are using for as a binding material for we are using for the cement and the concrete work, plastering, foundation, bridge and roads and precast elements. So all those we have particular application we are using for cement. So main properties of the cement will be high strength, same like the line, good soundness and proper setting time, durable and long lasting their life, increasing the durability of the structure. So eco-friendly, not only with the having additives, it will be eco-friendly cement. What is the advantage of the cement when compared to the lime? It's developed the high strength and more durable. It's set proper time. It be hard, it will be uniformly, and it will be a structure. So it's a binding material. It easily good binding with the aggregate and it strongly and provide the stability of the structure. The cement we can use it for the suitable various construction work. So can be manufactured with a color in quality also will be yes. Okay. So if not maintained properly for the construction of the cement, maybe chances of the failure also. There will be disadvantage of if the improper or the excess of the ingredient of the cement for different cement. So excess magnesia causes the unsound and it will be expansion. It will be there. Excess of the alkali it causes for the effluence and as well as the expansion. Okay. So improper gypsum content is to affect the setting time of the cement. So we can use for 2 to 5% of gypsum need to add for increasing the setting time. High quality of the cement may be costlier. So generate the heat during the setting time and hardening. So these are the cons of the cement. So what is important for this cement? The quality of the cement, it's mainly it's very depend upon the correction proportion and various ingredients present in the cement. The storing the cement in a dry place to prevent for moisture absorption. The use the cement before expiry date to best result we can able to achieve. When your package be open, we need to use for all those quantity of the cement. So using water cement ratio as per required for the strength and the durability, the follow the standard course and guideline testing usage of the cement. So we know good quality of the cement with the proper storages, handling and usages, ensuring the most strong and durable and safe of the structure. So we know these different type of the cement where we can be able to use in construction purposes. The first type of the cement is for ordinary Portland cements. Generally, abbreviation is OPC. So most widely we are used for this ordinary Portland cement for the building, bridges, and for the pavement constructions. Pozzolanic cement, the PPC, it will contain the pozzolanic materials. It will be a low heat of the generation and durable, used in the marine structures and dams as well as the mass concrete structure we can use for the PPC. And rapid hardening cement is again the strength is quickly when compared to the previous Portland C and the ordinary Portland cement. I used it for the road work, precast construction, and the emergency work which is required in building. We can use it for rapid hardening cement. Low heat cement that produce the less heat used in the dam as well as the massive construction work for all the hydraulic structure we can use for low heat cement. Sulfate resisting cement will resist the sulfate attack used mainly for the foundation and marine structure. Sewage work will be there. We can use it for the sulfate resisting cement. So white cement for the decorative purpose, tiles or finishes. For that we can able to use for white cement. High alumina cement we need for early strength or quick setting cement. We can use for high alumina cement. We are used for the refractory works, for the lining, industrial furnace, and high temperature application. We go for the high alumina cement. For quick setting cement, it will set very quickly after the pouring of the concrete. So used for the underground works. So mainly for repair work and grouting and anchoring underground or water level, we can use for quick setting cement. So hydrographic cement is very resistant moisture during the storage of the tank. So it's be used for humid regions. It will be long-term storage we can able to do, and rural and remote area we can use this type of the cement. So we know cement is a key. It's a binding material other than the next for in the line that hold sand and the aggregate will be together and providing strength and durability for to concrete, mortar, and into a plaster. So where we can use for different type of test we are seeing. Cement is a binding material. It gives the more strength as well as the durability. We're using the multiple application, especially for the various type of the building, bridges, roads, dams, tunnels, and marine and for other industrial structures also. So it provides the resistance to the environment, especially for the sulfate, moisture, heat, and chemical attacks. To enable the faster the construction, it will improve the workability and will be finishing. So this is be a cost-effective and economical essential for the modern construction work. So right type of cement is used in the right way to ensure the safe, strong, and durable and the sustainable of the structure. So now we are seeing the for manufacturing of the cement process. So during the manufacturing, different type of the steps are involving with the following stages. The first stage is when you are getting the limestone or raw material from the quarry. So we need to crush and we need to grind it. So raw materials like the limestone and the clay are be crushed, and other all the calcareous material and algareous material we need to raw materials we need to crush. So ground it will be a fine powder that that we need to make it as a fine powder. So after that, then we need to do for the mixing. So raw materials are mixed in a correct proportions. So after that mixing, we need to keep for the burning in a way clean. So we need for temperature of 1400 to 2500 degrees Celsius. So once it is done, automatically the forms the clinker. So next step is grinding of the clinker. So when say clinker is a bit cooled, during the manufacturing of the grinding purpose, we are going to use as a gypsum. When you're using the gypsum, the quick setting time will be increased. So finally, we are going to make a ground into the fine powder. So finally, the storage and it will be packing. The cement is stored in the large silos. So packed as per the cement bag for our normal construction purposes. So these are the sequence of the process of the cement manufacturing. So we are in two different method manufacturing of the cement. One is dry process as well as the wet process. So it's a dry process. The raw materials are be ground. It be a dry stated. It's a more commonly used for the during manufacturing process. It be very economical and efficient. When you see the wet process, raw materials are ground with a water to the form of the slurry. So at the dry material, we are going to add for the water. Automatically, this forms the slurry. So what is less commonly used to be today requires a more fuel and costlier to do the for wet process. So for dry process and wet process, we are using for one for the dry process that should be economical that ones. So dry process are more commonly used because the economical as well as the efficient. So we should know what are the raw materials we are mainly using for the cement is be limestone, clay, and etc. So when you're using for raw material, we need to burn minimum temperature 1400 degrees Celsius to 1500 degrees Celsius. So main product after burning, it will be a clinker will come. This clinker is using for grinding minimum 2 to 5%. So final product you will get. So proper manufacturing is the ensure the strength and durability and the quality of the structure. So now we are going to discuss about the aggregate. So aggregates are the inherent to the granular materials such as sand, gravel, and crushed stone used for cement to make the concrete. So this aggregate that both fine as well as the coarse aggregate take the main for 70 to 80% of the concrete should be volume. So we have three different type of the classification of the aggregate based on the size. Based on the size, we are classifying the two types. One is a fine aggregate and a coarse aggregate. The size will be less than the 4.75 mm, so that called for the fine aggregate. The size greater than the 4.75 mm is called the coarse aggregate. So for a fine aggregate, the example is a sand. Uh, Coarse aggregate example is a gravel, crushed stones. Based on the sources, so where we can able to get the aggregate, one is a natural aggregate, it's the optimum from the natural sources like a river, lake, and quarries. Then artificial aggregates, so manufacturing by crushing of the rocks, bricks, or other materials you can get for artificial aggregate. So recycled aggregate, so obtained from the construction and demolition waste, they reused after the processing. The next classification based on the shape will be a rounded. So automatically the periphery of the aggregate should be a smooth and spherical in shape. So irregular, uneven shape with a rough surfaces. All the sharp edges are corner, that is called angular aggregate. Flaky and thin will be in a shape, and elongated will be a length much greater than the thickness, that is called elongated aggregate. Then what is the main importance of the aggregate in the concrete? So provide the bulk and reduce the cost of the construction when you're using the properly for coarse and fine aggregate. So improve the strength as well as the durability. So provide the stability and reduce the shrinkages. So it will affect the workability and water demand and the finish. The proper selection will be ensure the quality and the economy of the concrete structures. We'll be having aggregate having different properties in the good aggregate. When using the good quality of the aggregate, it will be strong as well as it be hard. The aggregate it be to be clean and free from the dust, clay, silt, and organic matter. The proper shape as well as the texture is very required. Using the aggregate, it will be good adjustment with the cement paste to resist to wear, impact, and weatherings. So chemically stable and non-reactive, readily available and economical. So these are the properties of the good aggregate. When you see the aggregate, we can able to see the typical size. We can able to range that is the IS 83 is given for the different size ranges. So if you fine aggregate, if you say up to the 4.75 mm, so where we can use all type of the concrete and mortar plaster, this size of the aggregate we can use. The coarse aggregates will be a 10 mm. All the general construction work we can use. Coarse aggregates will be 20 mm. RCC work, foundation, slab, or beam we can use. The coarse aggregate is 40 mm. The mass concrete, damp, and large foundation work we can able to use for this type of the aggregate. So what's the key point we learned in aggregate? Aggregate from the skeleton of the concrete structure. Good aggressive, it improve durability, strength, and increasing the workability of the structure. So when graded aggregate reduce the voice and improve the density, the impurity in the aggregate reduce the strength as well as the durability. So proper selection of the and grading of aggregate are essential for good concrete. So aggregate is a vital is a component of the concrete. Their size and shape and texture and purity greatly influence the strength, durability, workability, and economy of the concrete. Yeah, in different characteristics of aggregate will be there. It's based on the aggregate ensure the durable and strong, high quality. I mean, we need to follow the different characteristics. One is the strength is a main characteristics. It should be resisting crushing under heavy loads and during the mixing in the compactions. It will be a hardness should be a resist to wear and abrasion during the handling and transporting and mixing of the aggregate. Their toughness should be resist sudden impact and sudden shock without breaking down. Aggregate should be a durability. It will resist the weathering action such as from the rain, frost, heat, and chemical attack. Shape will be well graded in cubical or rounded and not flaky or not elongated. Right? You can able to get the more bond. Size of the aggregate is very important characteristics. Should suit for mixed requirement and proper grading for a better workability and minimum required. So specific gravity usually should be as 2.6 to 2.8 for the most of the natural aggregate. And porosity, low porosity is preferred for high porosity, reduce the and durability. Water absorption should be a low to prevent the reduction in the strength and should be ensure the durability. So aggregates should be free from the dust, clay, silt, and organic matter and other deleterious substances. So quality of the aggregate, it improves the workability, strength, durability, and economy of the concrete. So when using the aggregate, it should be a stronger in the concrete, longer service life, the cost effective, safe and reliable structure, and sustainable construction for concrete. So when say next, yeah, this going next concrete be a concrete. So concrete is a composite material, so made by mixing of the cement, fine aggregate, coarse aggregate, and water. If you mixing, we'll get the new form. And after hardening, we'll get for harden like a natural stone. Cement is one of the binding material for ingredient of the concrete. Next, sand is less than the equal to 4.75 mm. This is called fine aggregate. Then coarse aggregate greater than 4.75 mm. Then for hydration purposes, for workability purpose, we are adding the water. We will get for finally for concrete. It's concrete, it will be a strong and durable for the construction materials. What are the component of the concrete? It is cement paste. So cement paste is contained for the cement plus India water. Then fine aggregate in form of the sand. Coarse aggregate in form of the gravel and crushed stones. The proportion and the quality of the ingredient it will be affect the strength, workability, and durability of the concrete. So we have different type of the grading of the concrete is based on the characteristic compressive strength after the 28 days. This table shows the different grade of the concrete from the M15, sorry, M5, M7.5 up to the M40. For characteristic strength of the concrete in after 28 days, how we are calculating the characteristic strength of the concrete, then we need to having a cube standard size that we need to keep in the compressive test. We need to apply the compressive forces up to the failure. The whatever may be the grade, that grade should not be less than that compressive strength. So for M5, we should be a minimum of 15 Newton for mm square. Up to like that, M40 means not less than the 40 Newton for mm square. So here we are having letters to be M, that is called for mix. A number is for characteristic compressive strength in terms of the megapascal or Newton mm square. We can able to note down. So we should know about the high grade of concrete should be high compressive strength. Selection of the grade is depends upon the types of structure and the loading condition of the structure. Quality of the material and the proper proportioning ensure the designing the grade. So curing and compaction are important to achieve the target strength. Standard codes like IFO 6 are followed to different grading and proportions. When you are using the application based on the grade, if you are having low grade M5 to M10, so PCC and blending in the concrete we can use. Grade of M15 to M20, you can use for RCC slab, beams and columns. If you're using the M25 to M30, most of the multi-story building we can use this type of the grade. M35 and M40, high rise and heavy load structure, we can use this type of the grades. So proper grading of the concrete will ensure the safety, economy and durability of the structures. So always use the specific grade as per design requirement and standard. So we are having different type of the properties of the concrete, mainly two properties of the concrete. One is the fresh properties as well as the hardened properties. And looking into the fresh concrete properties, the workability is very predominantly using important properties. So easily need to mix and placing and complex and should be more workable. So where you're using for workability purposes, ensure the proper placing and compaction without the segregation. So workability we can able to measure using for slump test. So high slump equal to be more workable. So low slump will be a less workable. We can able to calculate. So next properties of fresh concrete will be segregation. The segregation means separation of the ingredient. It will be a hard aggregate from the mortar. So it should be maintained uniformly and strength. The test for the segregation we can see for the visual observation itself. So a typical range, it is no visible in the separation of the segregation. So next property is a bleeding. When the water is rising on the surface after placing, that is called for bleeding. That means excess of water from the concrete mass. It should be low to avoid the weak surface, and for finish bleeding test we can able to do, that is a volume of water test. So low bleeding is preferred, less than 1 milliliter per centimeter square. So plasticity of other properties to easing of the molding and we are finishing. To help it achieve the desired shape and finish, the plasticity is very important. You can able to measure in a visual assessment. So good plasticity for easing the finishing. The setting time taken for the concrete to lose the plasticity and harden. So important for finishing, for form work, removal and construction should be planning. So for measuring for setting time for the properties in the vertical needle test. So initial testing time 3 minutes to the 2 hours, and the final setting time is 5 to the 10 hours for concrete. These are called properties of the fresh concrete. Then properties of the hardened concrete. So prime, it will be properties be strength, mainly for the compressive strength. It indicates the load carrying capacity of the concrete. So we can use for the composition test using the cube and cylinder. We can able to measure the compressive strength of the specimens. So typical range depends upon the grade. If you see the M20, then you get for M20 megapascal. If you use the M30, you get for 30 megapascal. So durability of the hardened concrete should be a resist to the weathering and chemical action. It will ensure the long life and low maintenance. So it will test chemical as well as the weathering test will be available. Based on that, we can able to see the durability of the test. High durability is required for it to survival of the building. Next property is impermeability. Impermeability is to resist the water penetration. So it will prevents the corrosion of the steel and damage of the existing structures. So we can conduct for the permeability test. So low permeability is to prefer, we'll get for more strength of concrete. So next properties will be a creep, slow deformation under the sustained load, that is called the creep. So the creep is be affect the long-term deflection of the structure. So we can able to do for the creep test to assess the for the our concrete. So the creep is depends upon the mix, load and the age. So it will be affecting fire resistance. So concrete should be ability to withstand the high temperature. To ensure the safety in the fire condition, then we can able to conduct the fire resistance test. So it will be depends upon the concrete density as well as the cover. So density, so mass per volume of the concrete. So it will be affected dead load and structural design. So we can do for the density test weight per volumes. So normal concrete 20,000 to 25,000 kg per meter square for the density of the concrete. So property of concrete is depends upon the what is the quality of the material used, mixed proportion, water cement ratio, compaction and curing. So next will be concrete blocks. So concrete blocks are precast, it be a solid or be a hollow blocks. So made up of the cement, aggregate as well as the water. So they are used for alternative for the bricks or stone in your walls. So what is the composition of the wall? It be a cement, one of the ingredients. They be aggregate and water will get for a concrete block. So we having a precast in mold. Now it will be a cure and then we use it for the constructions. So in a concrete block, and three types are there. One is a solid concrete block. It be very dense and it be very heavy weight, where like our clay bricks. So we can use for the load bearing structure wall for the solid concrete wall. So next will be a hollow concrete block. Will be contain the big cavities in between the blocks. So light in weight, using the partition and frame research, temporary stretch, we can use for a hollow concrete blocks. So aerated, the concrete blocks will be light in weight, good thermal insulation for this aerated concrete block. When you're using the concrete blocks, we having very different advantages also. So larger in a size than the bricks. So we having a normal size of the bricks. You started using the concrete block, the size will be bricks. So automatically reduce the number of joints and the speed of the construction. Now, when faster construction because it will be a larger size and uniform shapes to save time and will be a labor. Less mortar consumption. It's a bigger size means we can use for only for less mortars will be required. So composition it will be very high and will be a durable structure. It will be a better fire resistance, so non-combustible and offers the better fire performance. It is a concrete block, it will be a good sound as well as this thermal insulation. It will be economical. So automatically overall we are saving the materials in the construction. So it will be ideal load bearing partition and compound wall and all the type of the masonry structure we can use for this concrete blocks. So now we see the table the difference between the three walls. When you're using the solid block, the weight is be high. You can use for load bearing walls, foundation, and retaining walls. Futures will be high strength as well as the durability also will be high. The hollow block. So in the block, we having a cavity will be there. The weight will be very less. So we can use the partition wall, framework structure, and non-load bearing walls. So lightweight and easy to be handled. So aerated concrete blocks is very light. Partition walls and insulation wall and cladding walls, we can able to use this aerated concrete blocks. Thermal insulation and energy efficient for the aerated concrete blocks. So concrete in block will provide a very good strong and durable and economical construction solution. So we can choose the right type of the concrete blocks, either solid and hollow and aerated concrete based on the structural requirement and based on the load and the performance and needs. So when using the concrete block, it's very durable, the time saving, the cost effective and sustainable construction uses. As of now, what we discussed is we have seen the different type of the lime. It's where we getting the lime from the limestone, and I have seen for different classification lime, especially for fat, hydraulic, and poor lime. Then we discussed the most important binding materials for the cement and construction and manufactured by burning and limestone and baked clay. And discussed in the different type of the cement are used for different engineering needs. And aggregate will form major portion of the concrete and also be affected strength as well as the durability. And concrete grade based on the composition and fresh and hardened properties. And concrete block in modern wall unit used for faster and economical constructions. So all the together, the lime, cement, aggregate, and concrete block ensure the strong, durable, and economical construction. So these are the module outcomes. So now student can able to explain the various constituents of the limestone and different classification of the limes. Learner can able to describe the cement composition and how the manufacturing of the cement and various types of the cement can able to explain. Now you can explain the classifying and evaluate the aggregate used in the various construction purposes and concrete. Now you can able to explain the grading and properties of the concrete, and finally you can able to identify the application of the concrete in the construction work. So understanding materials built for a strong structure, we need to get for the more knowledge today, and strong foundations will be tomorrow. So we need to ensure that we need to select the quality of the materials and the quality of the construction. We'll get the better concrete and better of the buildings. Dear student, this is a textbook we are using for the building materials, the SK Tukal. For all the topics, what we have discussed, the lime, cement, aggregate, and the concrete, everything is be available in our building materials books. So thank you all. So very soon we are going to discuss about the next module. So thank you all.